Hi, this video is on a lesson from Envision. That'd be lesson 8-9 on solving problems involving volume. And I apologize at the beginning for the hokey pictures in the background. I literally just took a picture with my iPad of the textbook because our online textbook would not load for me today. And I wanted to be able to provide this video for you. So if you would just find your book and turn to page 472, let's look at the first example they have. So I'm first going to focus on this example they have worked out for us about an aquarium. The aquarium is in the shape of a trapezoidal prism. That's because the base of this aquarium, even here at the bottom, as well as the glass part, is the shape of a trapezoid. And it's so they're looking only at the glass part. So this trapezoid here is at the base, and it's 5 feet high. And so what is the volume of the tank? So to find the volume of the tank, to find volume of any prism, you find the area of the base and you multiply it by the height. That's what they're saying here in step 3. So in step 2, they're just finding the area of that trapezoid. So they use the formula, and then they plug in the values from the picture and found that the area of the trapezoid is 9 square feet. They put that into the formula for volume. Here's the 9. The 5 comes from the height of the glass part of the tank. And they multiply and they have the volume of the prism. So voila. The toughest part about this is just being able to use the correct formula for the base that you're given and to make sure that you're putting in the right numbers. So now we're down here at the try it. And my picture is kind of bent, as you can see, because of the photo. But if you want to, now you're going to attempt this one on your own, and then we'll come back and check our answers. So it's kind of like a fill in the blank. The base of this prism is the triangle, because the triangular prism. So remember, prisms are named for their bases. The base is not the rectangle on the bottom, but the triangle that we can see. And so we're going to find the area of that triangle, and it's a right triangle. So to find the area of the triangle, the things that go in the blanks here is 8, because the bottom of the triangle is 8, and 6, because the height of the triangle is 6. So that would give you 24 for the area of the triangle. Then the height, the other h, because there's a height for the height of the triangle, but there's also a height for the prism. That's 14, because that's the distance that the two triangles are apart. So 14 goes here. So then I would multiply those two. So I have 336 centimeters cubed. And so the volume of the prism is 336 cubic centimeters. It says, convince me, what is the shape of the base of this figure? And the shape is a triangle with the dimensions of 6 by 8. Now, we are not able to find the surface area of this triangular prism because they did not tell us this hypotenuse, the other side. I know it's 10, but without that information at this point, you would not be able to find the surface area, but you can find the volume because you know the base and the height of the triangle. So there is the first example in the try it. Let's go on to the next thing. So here we are looking at example 2. And in example 2, they're telling you the volume of this hexagonal prism, and they're asking for will the basketball fit inside? So it's almost like a yes or no question, but you have to give details. So the basketball is 6 inches in height, or its diameter is 6 inches across the whole basketball. And they know, for some reason, they know the volume of this box, but they don't know the height of the box, which I think we can all agree would have been a lot easier just to measure the height of the box than it would be to know the volume. But whatever, it's a math problem. It doesn't have to make sense. So the first thing is they're actually showing you the formula and how to find the area of a hexagon. I would not, at this point, worry too much about memorizing that or knowing that, Because what would most likely happen is if you were given a problem at this point about a hexagonal prism, we would just say that the area of the base is 42 inches squared and go from there. So what they're showing you is since we know to find the volume, you would multiply the area of the base times the height. They filled in the volume. They're saying the volume is 294 inches cubed. And so they filled that in the formula. And they're telling you the base, they figured out the base area to be 42 inches squared. So they've put that in the formula on the other side of the equal sign. And the thing they don't know, the unknown here, is the height, the h. So to find that, they do the opposite of multiply and they divide. And they say the height of this box must be 7 inches. And therefore, yes, of course, the basketball could fit in because it's only 6 inches. So that is an explanation for example 2. And then here's example 3. They're saying when you're given a shape, a composite shape of where we don't have a formula for it, like this house type shape is a shed, you would have to find the volume of both pieces and then put them together. And it's just like finding the area or surface area when you have to do two, you just have to add them together. So and I think we actually did a problem like this before in a warm-up a long time ago. So you'd find the volume of the base, you'd find the volume of the bottom cube, find the volume of the top, which is a triangular prism, and then just add those two things together. They finally then added them together, and that's what the work shows. So we're going to kind of take that and complete the try it. Now you can see in your paper, you definitely do, in your book, you don't have enough room to do this try it. I'm going to do it on here. I'm going to see that this L shape here is congruent with the L shape in the back. So that's going to be the base. So I have two options. I can either use this formula and to apply it to this shape itself, or I can find the volume of the two, I could break this into two rectangular prisms and find the volume of one rectangular prism, find the volume of the other rectangular prism, and then add them together. I'm going to actually do the first option. So I'm going to erase that part. And we're going to do option 1. And the first thing I'm going to do is I'm going to redraw this base here, this L shape. Oh, that's really bad. I'm sorry. And I'm going to label the dimensions. So this is 30 inches. This is 10 inches, and I'm taking that from the picture. So I got the 30 and the 10. I know that this down here is 40. I know that this 10, I'm going to come back to that. That's actually not on the base. That is the distance between them. It's the 12 that I need. The 12 is the dimension here. So now I'm going to find the area of this L shape. So to find the area of the L shape, I'm going to break it up into two pieces. So this rectangle here is 12 by 40, which is 480. And then the hardest part is for me to, maybe the one mistake I might make is I might think that this rectangle over here is 30 by 10, but it's not, because I've actually cut 12 off of here. So this is no longer 30. That means it leaves this side here with 18. That means this side of the rectangle, this smaller version of the rectangle that I've cut, is actually 18 and the top part's 10. So that means this is 180. So altogether, that L shape, the area of the L shape added together would be 180 plus 480, which is 660 inches squared. So that's the area of that L, which is the base of the prism. Now I know that there is there is a prism here, and so the height of the actual prism is this dimension here, this 10. So now I'm going to use the formula. The volume is the area of the base times the height of the prism. The area of the base is 660. The height is 10 because that's how far apart those L's are. So that means the volume should be 6,600 inches cubed. So that's how you would do a problem like that. So I'm going to ask that you solve number 7 and find the volume of that one. I'm actually going to ask that you do number 8 as well, but I'm going to give you some information here to start. So this first fill in the blank is just a matter of you putting in some of the information, and I put in the 6.1. That's actually what's called the apothem. It doesn't really matter though, but that's the number that you need to be able to find the area of the hexagon. This box that's empty is the number that's not plugged in yet. It's the 14, the height of the prism. This 128.1 is what happens when you do this math. This is the area of the hexagon. So now you just bring this information and you're going to finish that problem. So there's 7 and 8. And I'd also like you to do number 9 here. Let me get you started on that. So in this problem, number 9 is referring to this hexagonal prism. And they're telling you the volume of that prism is 3,572.1 to be exact. And then they're giving you the information. The thing they're not telling you is the height, or the area. So what I'm going to do is I'm going to tell you that what the area of the base is to kind of get you started. You need to know, can two cars, so here's a car, and this is 8 meters across. And here's another car. That's 8 meters long. And they're tethered together, they're connected by a 3-meter connector. So that all together, that whole thing from one end to the other would equal 19 meters. They're saying, can that actually pass through the tunnel at the same time? So in other words, is it more or less than 19 meters in length or in height? So let me give you the base area. So now you know that the area of the base is actually 170.1 meters squared. And you know that the length of the cars they're passing through is 19 meters. So the question is, was the distance from here to here more or less than 19 meters? And you would use the formula and the volume that they're given to figure that out. So I'd like you also to complete number 9. And then number 10, the volume of this concrete, so the volume of this ramp is 185.5 cubic feet. We don't know this number here. It says how long is the ramp, or in other words, how wide it is, or what's the height if we tilted it so that the triangle was the base. So you know that you need to use this formula, that the volume, which you do know, that will go here, equals the area of the base. So you're going to need to find the area of the triangle times the height. Well, the height is going to be the one thing that you don't know. So you're going to fill in the information you do know and solve to see what the height would be. And we are skipping number 11. I'd like you to do number 14, which is something that you actually did earlier in the Math Excel. You did a problem just like that, where you have the beam and you are removing this middle hollow section. So remember, you had to find the larger volume and subtract out the smaller volume. And then finally, number 15 says a cake that has 2 layers. Each layer is a regular hexagon. A slice removes one face of each prism. What is the volume of a slice? So the thing you need to know is the volume of the slice is actually going to be a triangular prism. So this is a challenge to anybody who wants to attempt it. It's not required, but you can try this one. You know, the missing piece is in each part is a triangle, so try to figure out what the dimensions would be and what the volume would be of that triangular prism that's been cut. And then think about how many would remain to be able to find part B. So that's it. That's the assignment. You are completing numbers 7, 8, 9, 10, and 14. Thank you for watching.